welcome, Matt Taylor here with another Math Methods tutorial. Today I'll be doing question 17 of the extended answer for 1.5. It's the last question, and the question asks, the section of a theme park ride has a central structure as shown below. So this is the equation. Well, it's not really the equation, that's the cross section of the theme park. So the diameter here of the top, is the radius of the base, and the height there. The sides of the structure can be modeled by y equals a over x squared plus b. The diameter on the top of the structure is 20 meters and the height of the structure is 40 meters. The base of the structure has a radius of 50 meters. Find the values of a and b. So the only way I could figure out how to do this question, do this part of the question, was by using solve and using two different points on the graph so that solve could work out the values, because it's got two variables in there. Like, there are four variables here, but we can find out these two by looking at the graph. And if you use two simultaneous equations in solve, it can find out that answer. I'm not sure if there's another way, but that's how I did it. So we can get 2 points from this. If we can see this point here, this is going to be 10 because diameter, half the diameter is 10. It's going to be 10 here. So when x equals 10, y is going to equal 40. So one of our equations is going to be 40 equals a over 10 squared plus b, and the other one's going to be 50 on the x, 0 on the y, so 0 equals a over 50 squared plus b, which I've done here. So I've done solve, put those two equations in, comma a, comma b, solving for both, and it gives you these values here. And you substitute them in for a and b, and you've got your new equation, and I defined it here for the other parts of the question. State the domain and range for the structure. So the domain and range for the structure goes from here to here for the domain. So it's going from negative 50 to negative 10, and then that's in union with positive 10 and positive 50, because it doesn't include that middle section there, but it only includes this part here and this part here. So negative 50 and negative 10 in union with positive 10 and positive 50, I should say. Part C. The ride has a carriage that moves down the outside of the central structure. What is the horizontal distance from the starting point when the height of the carriage is 20 meters? So for this one, I just did a solve. So we want to know what the value of x is, which is the horizontal distance when the y is 20, and it's got negative 13 or positive 13, but it doesn't really matter. It's going to be 13.86 meters away from, 13. That's going to be the horizontal distance. Part D. A junior version of the ride is proposed with the sides of the central structure dilated by a factor of 2 from the y-axis. Find the new equation. What will be the diameter of the new top and the new base if the structure is still 40 meters tall? Comment on how realistic this proposal is. So what this question's asking is if this part here and this part here were dilated by a factor of 2, in other words moved out this way, the base is obviously going to be wider and the diameter of the top is obviously going to be wider. So you got to find the new equation and then graph that, which I've done. Well, first of all, you got to find the new equation, obviously, and you get the a part, which is the dilation factor, and you multiply it by 4 to get the new dilation factor, and then that's the new equation. And it graphs here like this. Now this is a bit chaotic, but I've got everything just so it's easy for me to explain. This was the original equation, the graph of fx, which I defined previously, and you can see it goes up. I've got up to 50 meters here, so I think, was it 50? I think it was 40 in the question actually. Yeah, 40, but okay, goes up to about 40, about here or something. So we can see that. I'm going to actually just change the settings so that that's 40, so it's more accurate. Okay, and now we can see it goes all the way down there and across here, crosses through these points. So the question's asking, it wants you to dilate by a factor of 2. Originally I thought it would be this equation, so you just times it by 2, but if you actually look, it's not dilating it by a factor of 2. It's not a full double dilation. It's only about 1.5 times. So if you double it, well, multiply it by 4 or double it twice, you get this red equation out here, which is the correct one. You can see it's about twice as far away as the black graph here, the other one that I initially thought it was. But the question asks, Find the new equation. What will the diameter of the new top and the new base be if the structure is 40 meters tall? So the new base, you can see it goes, that's 100 there, negative 100 I should say. It goes all the way up to there, so the base is gonna be 200 meters for the diameter. And if I do a graph trace up here, I don't know if I'll be able to get all the way up the top, but from the looks of it, it's going to be 39.1, so it's going to be about 40 up there. So I'm going to say it's 80 across there for the diameter of the top. Now it says the last part, comment on how realistic this proposal is. I don't know. That's not a really good question for a maths textbook, in my opinion. It's like, it's not a maths question, but I don't know what the circumstances of this new ride are or anything like that. So, but according to the answer section of the book, it's because the new ride would be too big. Yes, it would be very big, but the question never said that they had some sort of limitations on how big the rides they make can be. So I don't know, but anyway, that's how you do question 17, last part of chapter 1.5. So thanks for watching, and I'll see you in another video.